Okay, this video is going to cover Chapter 10, Lesson 1, and it's Day 2. What we're going to focus on in this video is completing the square. So here is our first example. It's an equation that's in standard form, and we're going to change it into vertex form. So what we're going to try to do is we're going to go ahead and put it into x minus h squared is equal to 4p y minus k. Remember, in this vertex form, h and k, this is our vertex. So we're going to go ahead and we're going to complete the square. Now, just like we did at the beginning of the school year, when we did this earlier in either Chapter 3 or 4, I'm not going to move the 1 to the other side. I'm just going to shift it over. So I'm going to go ahead and I'm going to rewrite this. Y equals x squared minus 4x. And then I'll do like a parentheses. I'm going to leave a blank space. And then I'm going to put the plus 1. Now, when we complete the square, we should always make sure that the number in front of our square term is a 1. If not, we would have to divide. So we're good to go. So now what I'm going to do is I'm going to take this b term. I'm going to divide it by 2. So negative 4 divide by 2. And I'm going to square it. So I end up with negative 2 squared. And I get 4. This is what I need to, technically if I was doing it the other way, I would be adding 4 to both sides. But what I'm going to do is I'm going to add 4 here. But because this 1 should have been moved over to the y, instead of adding 4 to the 1, I'm going to subtract it. So now I'm going to simplify. Now, right now, in the parentheses here, I've made this into a perfect square trinomial. Now, if you recall what you got when you divided by 2 before you squared it, that's the number that goes in your binomial that becomes squared. I also need to simplify the 1 minus 4, and I get minus 3. And now I'm going to drop down the y equals. Now I'm going to move the 3 over. And I get y plus 3 equals x minus 2 squared. Now, remember, we want our equation to look like this. So I'm going to flip-flop, and I'm going to take the right side over here, and I'm going to move it to the left, and then I'll take this left side of the equal sign and move it over here. So I get x minus 2 squared equals y plus 3. Now, notice in this equation up here, I need a 4p value. So because there's not a number there, I can assume that that 4p equals 1. Now that I've transformed this into the vertex form, now I'm going to do the same thing that I taught you in Day 1. This has the vertex that is not at the origin. So again, remember the number, or when you're dealing with x, this is your h, this is your k. So my vertex for this equation is going to be the order pair positive 2, negative 3. Remember to find the p-value, we're going to take 4p, and I set it equal to this number that was in front here. And because there wasn't a number, it's going to be a 1. I'm going to divide by 4. And p equals 1/4. Now, I need to find the focus. I need to find the directrix. And I also need to find my axis of symmetry and an additional point. So I can already go ahead and I could graph my vertex. It's the order pair positive 2, negative 3. So I'll put my vertex right here. Now I need to find an additional point. Now, if you recall, when you have something in standard form like this, your y-intercept is your c. So remember, in standard form, it's ax squared plus bx plus c. So this is going to be my y-intercept. But again, what we could do is, if you're not sure, to find a y-intercept, we're going to set x equal to 0. So just to show you that it does give me the 1, y equals 0 squared minus 4 times 0 plus 1. Y equals 0 squared is 0. Negative 4 times 0 is 0. So y equals 1. So my additional point could be the y-intercept. So I'm going to go ahead and graph the y-intercept. And I'll put a point right here. I'm going to draw in my axis of symmetry. Remember, it's this imaginary line that goes through here. So far, I have the left side of my parabola. I'm going to use my axis of symmetry. So notice this is 2 spaces away from the axis right here. So I could go 2 spaces away over here. And then I'll go up to the 1. So I could put a point here. So my vertex, if you wanted to label it on your graph, is the order pair 2, negative 3. My additional point is 0, 1. I now need to find the focus point. So for my focus, we're going to use the vertex. Remember your non-squared term, it's the y. So I'm going to take the p-value, add it to the y. So I'm doing negative 3 over 1 plus 1/4. I need to find a common denominator. So I'm going to change negative 3 over 1 and make it negative 12 over 4. I can add this and I get negative 11 over 4. So you can either keep it improper. Since we're graphing this, I'm actually going to make it a mixed number. So it's going to be 2 and negative 2 and 3/4. So this is your focus. For the directrix, again, the variable that we added the p-value to was the y, so it's going to be y equals. And now I do the opposite of p. So to get the number that's going to go in here, I'm going to do negative 3 minus 1/4. So my directrix is going to be y equals negative 3 and 1/4. My axis of symmetry is the equation x equals 2. And now I'll go ahead and put in the directrix. So I'll come down here. And this is y equals negative 3 and 1/4. I can also put in my focus point. And it's at 2 and 3/4, so really close to the vertex. So that's your focus point. So again, we're going to identify the directrix, the focus, the axis of symmetry, the vertex, the p-value. So be able to find all of this information. Now, if the question asked to find the x-intercept, then I would set y equal to 0. Let's try this one. So again, we're going to complete the square first, and then from there, we're going to graph our parabola. It's got an x squared term, so we know it's going to look like a u or an upside down u. And in this case, because the a value is positive, I know it's going to be opening upward. Now, again, remember when you are going to complete the square, the number in front of the squared term needs to be a 1. So I actually need to factor out a 3. So I'm going to divide everything by 3. So this becomes x squared. This becomes negative 2/3 x. And then divide this by 3, and it becomes 4/3. Okay, so then now I'm not going to divide only the variables. Sorry. Okay, so we're only dividing the variables by 3. So again, I'm going to leave a blank space, and I'm going to shift the 4 over. So now I need to take the b term, which is the negative 2/3. I need to divide it by 2, which is really multiply it by a half, and then I need to square it. So I get negative 1/3, because the 2's could simplify, square it, and I get positive 1/9. Now, again, what I'm going to do is I'm adding 1/9 here, and what I'm going to be doing here, though, when I go to put in the number here, I have to take into consideration the 3 that I factored out because I didn't apply it to the 4. So I'm going to take my 1/9 and I have to multiply it by this 3. And then what I'm going to actually be subtracting over here is 1/3. Again, opposite of what you would think. So as long as this a term or this number here is positive, this is always going to be a subtraction. If this number was negative, then I would be adding that term. So now let's go ahead and we need to factor. So y equals 3. And then if you recall what you got when you divided by 2, becomes x minus 1/3 squared minus 4 1/3. Now, I'm going to actually make this improper. I'm going to make this 13/3. Okay, so now I'm going to move the 13/3 to the other side. So y plus 13/3 equals 3x minus 1/3 squared. Now, what I need to do now is I want the squared term on the other side. So I'm going to flip-flop the two sides. So I'm just going to take the right side, move it over here to the left, and then the left, move it over here. So all I did was switch the two binomials on either side. All right, so now again, remember, you only want the x squared term to be by itself. So what I need to do is divide both sides by 3, because I need that 4p. So x minus 1/3 squared, and then I'm going to make this 1/3 y plus 13/3. Now I have it in vertex form. My vertex is a fraction, but that's okay. So again, I'm going to pull it out, h, and then k, opposite of what you would think. So that's the vertex. Remember, we also need to find the p-value. So I'm going to set 4p equal to 1/3. Again, I'm going to treat it like a proportion. I'm going to put a 1 there. So I get 12p equals 1. Divide by 12, and p equals 1/12. Now I'm going to use that p-value later on when I'm finding my focus and my directrix. Now at this point, this was the same thing we did in day 1. So let's go ahead and let's come up with an additional point. Now we could graph this vertex. 13 1/3 is like negative 4 1/3. So just so I'll have a better idea of where to graph this. So I'm going to come over to the right to 1/3, and I'm going to go down to 4 1/3. 1, 2, 3, 4, negative 4 1/3. So I'll probably put my point about there. So that's going to be my vertex. Now, what I'm going to graph next is I'm going to find the y-intercept. So again, easiest way is if you go back to your beginning, again, when it's in this standard form, this is your y-intercept. Again, if you want to see the math, you set x equal to 0. So you do 3 times 0 squared minus 2 times 0 minus 4. And you get y equals negative 4. So again, shortcut, it's just that c term. So here is my y-intercept. So let me go ahead and make this in blue. That's the vertex. And then here's the y-intercept, 1, 2, 3, 4. So again, my axis of symmetry is going to be this x equals 1/3. I've got the left side of my parabola. And now I could use the axis of symmetry to get the right side. So 1/3 away, and then right there on the 4. So I could go up like that. So there's your parabola. Now I need to find the focus, and I need to find the directrix. So for the focus point, remember you take your vertex, which is 1/3 and negative 13/3. I'm now going to take the p-value. I add it to the non-squared term, which is the y. So I'm going to add 1/12 to negative 13/3. I need to find a common denominator. It's going to be 12. I'm going to multiply it by 4. So once I multiply it by 4, 13 times 4 is 52. So that's negative. So now my new focus point is going to be negative 51 over 12. So 1/3, comma, negative 51 over 12. So we could also make this a mixed number if you wish. 12 goes into 51 4 times. 3/12, 1/3, negative 4, and 1/4. Just so we can see approximately where to graph it. So 4 and 1/4. So again, really close right there on the axis of symmetry. So this is the focus. Now you could leave it improper, or you could make it the mixed number. For the directrix, what we need to do here, again, we're going to take that y value, the negative 13/3. This time it's the opposite of p, so I'm going to minus 1/12. So again, a common denominator. So negative 52 over 12 minus 1 over 12, negative 53 over 12. And again, it's an equation, and it's y equals negative 53 over 12. Now, again, we could divide and make it a mixed number. So then this would actually become negative 4 and 5/12. So again, negative 4 and 5/12. So just before the 5, maybe a little higher. My graph's kind of tiny, so it's hard. So, but here would be the directrix. And it's the equation y equals negative 53 over 12. Now, just in case you're asked to find an x-intercept, let's practice doing that. I know we've done it before. We can either do the square root method, or you could do quadratic formula using the beginning. But let's go ahead and plug in. So to find the x-intercept, if you're asked to do that, you're going to set y equal to 0. I'm going to use my newly formed vertex form. If you use the original, you could do quadratic formula. So I'm going to plug in a 0 here for the y. So I'm going to go ahead and simplify this. I'm going to distribute the 1/3, and I end up with 13 over 9 x minus 1/3 squared. So what I need to do is use the square root method. So then I get x minus 1/3 equals plus and minus root 13 over 3. I'm then going to add the 1/3, and x equals 1/3 plus or minus root 13 over 3. Now, you're not going to be expected to graph this, but if you're asked to just label the x-intercept, again, we would write it as a coordinate. So you can either write it like this, or you could pull it apart and you could say that it's 1 plus root 13 over 3, comma 0, and then 1 minus root 13 over 3, comma 0. Either way. So again, it's going to be kind of hard to graph a radical, but if it asks you to list it as one of your answers, this is the process you would follow. Let's do one more example. This time it'll look like a C because we have a y squared. So let's go ahead, and we're still going to follow the same process. Now, remember, we cannot have a number here in front of our squared term, so I need to factor out a 1/3. So this becomes x, and then 1/3, and then y squared minus 3y, close that parenthesis, and then put the 2 outside. So now that I've gotten rid of the 1/3, because I divided everything by 1/3, dividing by 1/3 is like multiplying it by 3. Next thing I'm going to do is take that b term, divide it by 2, and square it. So it becomes negative 3 over 2, and then I get 9 over 4. So this is what's going to be added here, but remember the number that goes here, you have to take in consideration the 1/3 times the 9/4, simplify. So what I'm going to be subtracting is 3/4. So opposite sign. So now I can factor this. Again, you don't need to think about it. Just remember what you got when you divided by 2. So y minus 3 over 2 squared. I need to do the math here and do 2 minus 3/4. So once I do that, let's go ahead and find a common denominator. Common denominator is going to be 4. And then I get 5 over 4. So plus, let's put it in blue, plus 5 over 4. Because that's what I got when I subtracted those, because signs were different. I'm going to move the 5/4. So x minus 5 over 4 equals 1/3 y minus 3/2 squared. Now again, I'm going to flip-flop it. So I'm going to take this, move it to the left, take this, move it to the right. I'm not doing any inverse operations. I'm just flipping my equals, the two things on either side of the equal sign. Next, I need to get rid of the 1/3. So I'm dividing by 1/3, which is really multiplied by the reciprocal. So my equation becomes y minus 3/2 squared equals 3 times x minus 5/4. I now have gotten it in the correct vertex form. Now, remember, what's with y is the k, and this is h. So my vertex is 5/4, comma, 3/2. Now, for graphing purposes, this is 1 1/4, and this is 1 1/2, just so we have an idea of where to put our vertex. So 1 1/4, and then I'll go up to 1 1/2. So probably about here. So this will be my vertex, and you can either, when you label it, leave it as the improper or the mixed number, either way. Now, the next thing I need to do is I need to find an additional point. Again, if I go back to the beginning, this is my, well, this isn't my y-intercept. So what we can do here is this is actually our x-intercept, but let's go ahead and see it. So to find the x-intercept, I'm going to set y equal to 0. So x equals 1/3 times 0 squared minus 0 plus 2. So x equals 2. So now I have an x-intercept of 2, 0. So that could be my additional point. I'm going to draw in my axis of symmetry. My axis of symmetry is actually going to be the equation of y equals 1 1/2, or 3/2. Now, I'm going to draw in, I've got this side. So now I could go 1 1/2 away up this way, and then go over to the 2. Now, next I need to find my focus. So I'm going to take my vertex, and I'm going to add the p-value. Oh, I didn't find the p-value yet. Let's do that next. So again, 4p equals this number here, which is actually no, this is the simplified one. I set it equal to 3, divide by 4, and my p-value is 3/4. Lots of fractions here. Okay, so my non-squared term this time is going to be the x. So I'm going to add the p-value to the x. So my new focus, or my focus point, 1 1/4 plus 3/4 is 2, comma, and then the y stays the same. So I'll come over here to 2, and then 1 1/2. So right here is the focus. For the directrix, again, you're going to look to see we're adding it to the x. So I'm going to take 1 1/4, and this time I'm going to do opposite of p, so minus 3/4. So my directrix, if I do a common denominator, and I change 1 1/4, well, it's already got a common denominator, but let's make it improper, just so it's easier. So 4 times 1, so 5/4 minus 3/4, and I get 2/4, or 1/2. So x equals 1/2 is the directrix. So right in here. So I found the directrix. It's x equals 1/2. I found the focus. I found the p-value. I found the x-intercept, my additional point. I found my equation in vertex form. I found the vertex. Let's also, actually there's no y-intercept. So you could say that there's none because it never touches the y-axis. So that is it for this one. So that is a review of completing the square. The same technique we did before back in the previous chapter. So here is the solutions, or I'm sorry, the homework. It's 19 through 30 all. In the homework assignment, I am going to list the answers for the even problems. It won't have the work, but I'm gonna put what the vertex and everything that the question is asking for. So I'm gonna list them, and I'll put it as a link in the homework assignment. So you can go ahead and work on this, and this homework assignment is going to be due on Monday. Actually, sorry, this is the same homework assignment. This is still 10.1a, and I'm going to say the same thing. I'm going to add the even answers to the assignment, so at least you can check it, and then when I see you on Friday, if you need to see any of them explained because you've gotten them wrong, I'll work them out. So that is it for completing the square. I'm going to give you practice problems for completing the square, and they'll be due on Monday.